Okay, the two key trigonometric functions to know the derivatives are these two. So the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Here's a couple reasons why. We'll just take a look at the derivative of sine x for this. And the first reason is through an algebraic proof. So what we're trying to calculate is the derivative of sine x. And we can do that by taking a look at the definition of derivative. So the limit as h goes to 0 of sine x plus h minus sine x all gets divided by h. This part here we can expand, so I'll do that next, and then I'm going to do some factoring to that. So let me expand it. There's the expansion, take away a sine x, all divided by h, and I'll move some of these items around and factor. And I'm going to separate this into two limits. And hopefully you'll see that this part here is equal to 0, and that this part here is equal to 1, and we have our derivative. Let's also take a look at the graphical approach to this. So we'll start with y equals sine x, and hopefully you can graph this fairly quickly. There's an estimate. Let's take a look at the derivative. At 0, the slope is about 1. In fact, it's exactly 1. And here, at pi over 2, the slope is exactly 0. As it is here, the slope is exactly 0. Here, the tangent slope is negative 1, and here again returns to positive 1. It is decreasing through here, so this decreases, then it starts increasing again. And I have a cosine graph as my derivative graph to the sine graph. Another way to do this is a technology approach. So I'll leave this for you, but you could graph y1 as sine x, and you could graph y2 as n deriv of y1, and you will see that this graph is the cosine x graph. And one really cool way to see it is if you do y3 as cos x and you make this bold, then you'll actually see it overlap on your TI-83, TI-84. So you should try that. Make sure you can actually use those functions of your calculator. There are also 4 other trig ratios, so we need to know the derivatives for those. They are the derivative of tangent x, which is secant squared x, the derivative of cotan x, which is negative CSE squared x, the derivative of secant x, which is secant x times tan x, and the derivative of cosecant x, which is negative cosecant x cotan x. Make sure you know these 6 derivatives, because we're going to need them to be able to do examples such as find the derivative of 3x squared cosine x. This is a product rule. When I calculate the derivative, I take the derivative of the first part times the second part, then I add the first part times the derivative of the second part. Ta-da! Okay, next example. To find the tangent line equation for our function at x is equal to pi over 4, I'm going to use the point slope equation, and so I'm going to need to know what's the value of my function at pi over 4. So I'm calculating 1 over tangent at pi over 4. Luckily for us, that's a fairly easy one to do. It's 1 over 1. So 2. So I have a point now on my graph, which is this point. I'll use soft brackets. So there's a point. So I now need to find the derivative. The derivative is 2 times negative cosecant squared x, or negative 2 cosecant squared x. And I need to find my slope, which happens at pi over 4. And so I get negative 2 cosecant squared of pi over 4. Hopefully you remember how to do these ones. It's the same as negative 2 times 1 over sine squared of pi over 4. Give myself some more room here. Sine squared of pi over 4. Pi over 4 gives us an angle of 45 degrees, so it's 1 over root 2. So it's negative 2 times 1 over root 2, all being squared, which is negative 2 times 1 over 1/2. 1 divided by 1/2 is the same as 2, and I get negative 4. I remember that my point is pi over 4 comma 2, so I can use y minus 2 is equal to the slope times x minus pi over 4. To get my point slope equation of a line, I can manipulate this to get negative 4x plus pi plus 2 if I wanted into a form of y equals mx plus b.